Hi, welcome to lesson 2G, inverse functions. The goal of today's lesson is to understand the power of inverse functions. For a quick review, we want to take a look at basic operations and their inverses. So as you know, the basic operations would be addition, and the inverse would be subtraction. Basic operation of multiplication, the inverse is division. And a basic operation of raising something to the power of 2 is the same as taking the square root of that base. Now, as you learned in grade 9, when solving equations or rearranging formulas to isolate a variable, it was necessary to perform inverse operations. So to rearrange the formula for the area of a circle, a equals pi r squared, when we were trying to find the radius of the circle, the result in performing these inverse operations would give you r equals the square root of a divided by pi. Because we would divide both sides by pi, and then we would take the square root of both sides to result in just the radius. In terms of functions, we can do the same kind of thing. We can view these processes as two machines. If they are inverses of each other, then the second machine undoes what the first one does. So if we have some input of 1 into this machine that converts 1 into 2x plus 3, we would substitute 1 in for 2, or sorry, in for x, multiply 2 times 1, add 3, and we would get 5 as the output from the first machine. That 5 then becomes the input of the second machine, and the second machine, as we were stated here before, undoes what the first machine does. So instead of multiplying by 2 and adding 3, we're actually subtracting 3 and dividing by 2. So that 5 comes in, we subtract 5 minus 3 to give 2, and then we divide by 2, and 2 divided by 2 gives us 1. We could look at those two machines as the very popular lawnmower and the lawn anti-mower. The first machine acts as a lawnmower to cutting the grass, and the second machine would then be the lawn anti-mower replacing the grass. Hopefully you don't have too many people in your neighborhood who have the lawn anti-mower who would come around and replace the grass on your lawn after you have spent a while cutting it in the summer. Okay, so if a function y equals f of x has an inverse function, then this new function is denoted f inverse of x. And just a little note to the side here, that f inverse is not the reciprocal of f, where we've seen in the past x to the minus 1, x to the negative 1 equals 1 over x. That is true. However, in this case, when we're dealing with functions, f inverse does not mean the reciprocal. It just means the inverse function. So this new inverse function must also be a function, because if y equals f of x is a function, then the inverse must also be a function, and henceforth must satisfy the vertical line test. And this new inverse function is a reflection of the original function y equals f of x in the line y equals x. And if we're then to take composites, the original function f and the composite of f inverse of x, then that composition of functions would leave you with x, whether it's f composite f inverse or f inverse composite f. They both result in x. The function y equals x defined by, and the f did not come out in that the conversion from Word to this notebook file. So y equals x defined by the function f such that x converts, or x is converted into x. That is called the identity function. let me just highlight that for you. So that is the identity function here. Since y equals x is the identity function, reflecting the function in the line y equals x has the effect of interchanging x and y. Therefore, if xy lies on function f, then yx lies on function f inverse. Okay, so just the x and y's have been interchanged from one function to the inverse. Therefore, if they have been interchanged, that means that the domain of f inverse is actually the range of f, and the range of f inverse is the domain of f. Okay, so for example here, if we have function f such that y equals f of, or 5x plus 2, and that function f becomes f inverse such that x equals 5y plus 2. Okay, so notice that the x and the y have just been interchanged. Y equals f inverse of x is the inverse of y equals f of x. In this function here, see y equals f of x is 5x plus 2, the y-intercept of 2, and it has the gradient of 5. And that becomes f inverse, where the x-intercept, in this case, is 2, and the gradient is actually 1/5. Because if we were to rearrange this and solve for y, the gradient would be 1/5. So that function, f inverse, is also a function, because if we were to draw vertical lines through y equals f inverse of x, then that line would pass the vertical line test. Thus, any vertical line would only cross that line once. And it is a reflection of y equals f of x in the line y equals x. Now, one way to do this, and I'm not sure if I can get lines to draw here nicely for me, but if we were to draw some lines perpendicular to the line y equals x, we see that points on the original function and points on the inverse function would line up. Now, these green lines I'm drawing are being drawn supposedly, and they should be anyways, perpendicular into the line y equals x. And thus we would get reflections of lines of points, from one, the original function, these points, in the inverse function. Okay, just by interchanging x and y, the x's and y's would just get interchanged with each other. Just a little point of interest. The reciprocal function, f of x equals 1/x, where x does not equal 0, otherwise it would be undefined, is said to be self-inverse function as the function itself equals the inverse function. This is because y equals 1/x is symmetrical about the line y equals x. And any function that has an inverse and whose graph is symmetrical about the line y equals x is called a self-inverse function. So just a quick little, if I can draw a quick little sketch here. So if we have the inverse function, I'll just draw the line y equals x here. And the function itself, if I can draw this to any degree of accuracy, the line y equals, or the graph y equals x looks something similar to this. That function is symmetric about the line y equals x. So if we were to do the same thing as we did here by drawing vertical lines, lines perpendicular to the line y equals x, we would find that we would be able to get lines. Use the green again, and this time I'll try to use a thinner line. If we were to draw lines perpendicular into the line y equals x, if I were to draw this correctly, then these points would just be points that are interchanged, x and y. Okay, so that's kind of the idea. So that would mean that this graph is symmetric about the line y equals x, which then tells us that the function itself is a self-inverse function.